Here we have question 13, and we're asked to find the angle between R and I. Okay, but the problem is with R is we've currently got two unknowns. Okay, so we can't figure out what the angle is between R specifically and I. But what we can figure out is the angle between this parallel vector and I. Okay, because these are going to be the exact same thing. So let's draw out this parallel vector, 3, -1, and let's draw out what I would be. Okay, so R is parallel to this vector here. Okay, so even if R was, I don't know, like this, then you still have the same angle, because this is going to then be your I. Okay, so the point being here is that the parallel vector to R is going to have the same angle between I as R does. Okay, so what angle is this between I and 3, -1? Well, we draw out our triangle, then we use SOHCAHTOA. Okay, we've got the opposite and the adjacent. So we've got the tan inverse of a third, which is 18.4 degrees. Okay, and we're going to specify that this is below I. Perfect. Now part B. Show that P plus 3Q is 11. All right, so how can we create this formula? Okay, you've got to first start at what is something that I can solve. Okay, and I'm sure some of you might have tried to solve R equals F1 plus F2, kind of equated it to this parallel using a scale factor, and then got to that point and thought, oh no, I can't find this angle anymore. Okay, but use that from part A. And if you didn't do that and you spotted this A first, perfect. Okay, but in this part 2, we're using the standard method that we find the angle between R and I. Kind of part A has kind of helped us along that way. Okay, so what is R? Okay, at one point we should figure this out. At one point this should be useful, even just picking up exam marks. So 4 plus P, and then Q take away 5. So this is R, and this is parallel. So 4 plus P, 5 take away 5 is parallel to R3 -1. Okay, so we have the scale factor of lambda. Okay, now we need to cancel out lambda, and I'd bet a lot of money that this is then going to come out at this. Okay, so let's try that out. 4 plus P equals 3 lambda. That's the top equation. And then Q take away 5 equals -lambda. That's the bottom equation. Okay, let's make these times by -3 on both sides. Okay, now we can make these equal each other. So 4 plus P equals -3Q plus 15. Okay, and as you can see, we're getting to the form that we want. P plus 3Q equals 11, which is exactly what we wanted. Okay, and this is problem solving, that not knowing how you'd choose to do that step, which is the hard bit. The actual algebra behind this is not difficult, okay, but it's trusting that this is how we can create a formula in terms of F, P, and Q. Okay, knowing we've got enough information with this resultant vector being parallel to this vector that can give us an equation in terms of P and Q. Okay, now given that P is 2, find the magnitude of R. Okay, so P is 2, which means that 3Q equals 9, so Q equals 3. Okay, what was our resultant vector? Our resultant vector was 4 plus P, Q take away 5. Well, we've got P, which is, so now 4 plus 2 is 6. Then we've got Q, -2. So this is going to be the square root of 36 plus 4. And in this chapter, if you get 2 root 10, well, about 3 out of the 14 have been that. So I think you'd be correct.